Hi everyone, I'm Yu. Today, I'll present our work, Generalizable Knowledge Distillation from Vision Foundation Models for Semantic Segmentation. Let's start with the standard knowledge distillation setup. A large teacher model transfers knowledge to a compact student, either at the feature level by aligning intermediate representations or at the response level by matching logits. The student is then optimized jointly with a task loss and a distillation loss. This single-stage joint optimization is the conventional recipe. However, this conventional recipe has a critical blind spot. Existing KD methods optimize in-domain accuracy, but overlook domain generalization. Meanwhile, Vision Foundation models like DNOV2 are remarkably robust on unseen domains. So a natural question arises, can we distill that robustness into a compact student? Our experiments show that conventional KD fails to transfer this generalization. The student inherits source domain bias and breaks under distribution shift. Why does this happen? Look at the conventional KD objective. The task loss and the distillation loss are optimized jointly on the same parameters, and these two objectives conflict. The task loss pulls the student towards source-specific decision boundaries, while the distillation loss tries to keep it aligned with the teacher's domain-invariant representations. The two gradients fight each other. The evidence is clear in the loss curves on the right. Single-stage KD oscillates throughout training. Once we decouple the two objectives by first distilling features and then freezing the encoder to train the decoder, the loss becomes smooth and cross-domain MIOU jumps by several points across all four backbones. This decoupling principle is the foundation of our framework. Building on this insight, we propose GKD, a multi-stage framework. Stage 1 is domain general distillation, performed in 2 steps. Step 1 is task-agnostic distillation on ImageNet, which closes the initial representation gap between the ImageNet initialized student and the VFM teacher. Step 2 is domain-agnostic distillation on the source domain without using labels. The student learns task-relevant features without inheriting supervision bias. Stage 2 is task learning. The student encoder is frozen, and only a mask-2 former decoder is trained with segmentation loss. We also introduce query-based soft distillation, shown in the bottom left. Student features act as queries to retrieve teacher features through attention, internalizing the teacher's relational spatial structure rather than imitating point-wise activations. We evaluate on 5 domain generalization benchmarks under 2 settings. F2L, Foundation to Local, where the student is locally trained, is shown in Table 1. F2F, Foundation to Foundation, where the student is a smaller VFM, is shown in Table 2. In F2L, GKD improves over the best prior KD by more than 10% on average. In F2F, the gain is consistent at around 2%. Notably, DayTB with GKD reaches 57.9 MIOU, essentially matching DINOV2B with the same parameter count but only ImageNet pre-training. Additional results confirm the robustness of GKD. Under limited labels, GKD, with only 1/16 of annotations, outperforms full data baselines. Scaling up source domains gives consistent further gains. The ablations confirm 2 things. First, multi-stage decoupling contributes most of the improvement. Second, every component of query-based soft distillation adds measurable benefit. These PCA visualizations make the effect of query-based soft distillation tangible. The teacher, DNOV2L, exhibits a clean, domain-invariant spatial structure across cityscapes, BDD 100K, and mapillary. The DayTB student and the AFDCD baseline produce fragmented, inconsistent features. GKD recovers the teacher's spatial structure across all 3 unseen domains. The qualitative segmentation results show the practical benefit. Compared with DA-Former and VICT, GKD predicts cleaner object boundaries, as you can see at the bus and sidewalk, and better preserves small structures like poles and traffic signs, especially under challenging conditions like the rainy BDD scene. To summarize, GKD decouples representation learning from task learning and uses query-based soft distillation to transfer robust generalization from VFMs to compact models. Thank you.